This is a walkthrough of the model for the Something's Fishy BioGraph activity. I've opened this model in edit mode so that you can see not only the 3D world, but also the blocks that make up the program for this model because they're used in this activity. Let's start with the interface. The representation of this model is that there is a fish pond, which is shown here, and it is populated with fish and their food source, which we say is algae or something like that. Um, the algae grows in clumps, and the clumpiness of those clumps is controlled by this slider here. And then there are 3 different types of fish populations. As I said, this is the yellow fish. You can also create multicolor fish, and in this scenario the fish have different colors, but that color difference is merely cosmetic. There's no other difference in terms of their behavior or their suitability for survival in this environment at all. The only difference is how they appear. The third scenario is the multi-trait scenario, and in this scenario the color actually denotes a difference in the trait of these fish. So the red fish are fast reproducers. They only need to save up a little bit of energy storage before they have enough to produce offspring. And the offspring that they produce, they create many offspring, but those offspring have low energy reserves when they are created. Then on the other end of the spectrum we have magenta fish, and magenta fish require high energy reserves to reproduce. They produce fewer offspring, but those offspring have higher energy reserves. And so in an environment where the algae is in these clumps and there are spaces between them, you can guess that there may be some selective advantage or disadvantage to having higher or lower energy reserves in these offspring. To run the model, you just click on whatever scenario it is that you want to set up, and then you click any of these run buttons will work, but each of the experiments has its own run button, and you can run the simulation for that number of seconds, which will be several generations of this fish pond. When you're running multiple experiments, sometimes it can be helpful to increase the engine speed using this slider up here. And that way, if you increase it all the way to 60, then you can finish a model in just a few seconds. This activity also has you look at the programming for the model. And so I'll scroll down here to the programming area, and it has you look at the program for fish. And as I said, there are 3 different run buttons: run for 30, run for 60, and run for 90. But notice that the programming for each of them is exactly the same. So the only difference in these scenarios is basically how long it will run. While it's running, these commands are executed over and over, repeatedly for every fish, or every fish follows these commands. And you can see that those commands are moving forward by a bit, setting its energy to energy -1. So in other words, decreasing the energy. Turn a little bit, swim up or down, reproduce if enough energy, and die if no energy or too old. The eating algae part comes here on collision with algae, and then it follows these instructions. It will delete the calliope, so the fish will delete the algae, and the fish will set its energy to energy plus 14. I forgot to mention the data boxes here in the interface that show you information about your experiment. When you set up, the clock is reset to 0, the algae population is somewhere around 500, and the fish populations, or the fish population is approximately 48 fish, um, and it's generally 12 of each color. This can sometimes be slightly different depending on the setup, because you may set up one fish right in the middle of a clump of algae and it may eat some right off the bat. As you run the simulation, the clock increases, and you can also watch the numbers of the different colors of fish change, and you can see the size of the algae population changing as well. And that's it for the Something's Fishy model.